can do here. The spacecraft is now on its own batteries. That has been checked by Baikonur and by us as well. And now we're crossing fingers and eagerly waiting.
Okay, let's cross fingers and everything else we can cross. Micha, thank you so much. 4 minutes, more or less, to take off. And I need an expert now on stage because we're getting very close to a very exciting moment. I need someone who can talk us and walk us through what's happening, and we just have the perfect person here. Michael Kahn, he joins me on stage. He's an expert in mission analysis, and incidentally, he's calculated the flight trajectory of Exomars. Michael, nice to have you here.
Thank you.
Okay, you talk us through the launch and the early stages, but we're not there yet. We still have a few minutes, so perhaps you can first tell us a bit more about this launch pad in Baikonur. Where is it? Why are we there?
Baikonur is the launch pad that's used mostly by Russian launch vehicles, and it's in Kazakhstan. It's not in Russia. It used to be in the Soviet Union, but then now they have a contract with Kazakhstan to keep on using it. And it's a vast, it's really huge, it's an enormous place just in the middle of nowhere. And that's precisely why it was chosen, because it is in the middle of nowhere. So
okay.
If something goes wrong, you don't hit anyone.
It's a shy launcher. It wanted to be all alone. And of course, we have actually pictures of the rollout of the launcher. And in a moment, hopefully, we'll be able to see that, because this huge rocket, it wasn't always in Baikonur. It had to be brought there. There we see the lander still. Tell us, bit by bit, what's been happening there on Friday.
So here we see the spacecraft with the TGO with the EDM mounted on top already, and it's being brought into the horizontal position, because that's the way Russian launches work. Everything's integrated horizontally. In Western rockets, it's vertically, and it's much more complicated, but of course it's kinder on the payload. And here you have to be careful. You have to change it from 90 degrees to 0 degrees, and then move it in. Here you see one half of the fairing coming in. It's integrated already, the lower half of the fairing. That will protect the payload during the ascent from the thermal and load and the drag forces of the atmosphere. Here it's being closed, and here it's on a train. So yeah, it's transported from the integration facility to the launch pad by train, of course, very slowly, very carefully. And you can see that there's kind of hood on the fairing with pipes going in and out, and that's air conditioning, so you have a controlled environment underneath the fairing all the time.
Okay, they're all really, really very careful to lift it now. I think they're raising it now.
Yes, now it has to, now finally it has to be brought to the upright position so it can be launched. And it will stand there. It's just freestanding. It's not clamped down or anything. So this was on Friday, and today it was, the lower 3 stages were filled with 620 tons of propellant. The upper stage, the 4th stage, the breeze, had already been filled before it was integrated.
Okay, and I think, Michael, now that we know what's been done before the launch, it's ready for us to concentrate on the launch, which is happening in about a minute from now. That's a good moment for us to just stay quiet and let you watch as things unfold. We'll pick up with you later again.
Самое точное приведение. Внезапно двигатели первой ступени.
I think it is safe to say that Exomars has lifted off into space successfully. That means the very first European-Russian Mars mission is on its way. Well done. So Michael Kahn, again, expert in mission analysis, and you've calculated the flight of Exomars. You're still with me, of course. Sadly, it was a bit overcast, so we couldn't see all the stages, but you can tell us what is happening next. I mean, as we speak now, the first stage, I believe, is almost burnt out.
Yeah, the first stage burns out in 2 minutes. So it goes through more than 400 tons of propellant in just 2 minutes. Mm-hmm. And by then it will have reached more than 40 kilometers of altitude and be traveling at 6,000 kilometers per hour. That's always the thing with rockets. First you go up and then you go fast. So you have to get out of the atmosphere, and then, so it's separated now. We can see that in the animation. And what they do is a hot start of the second stage. So it starts while it's still attached, so in a split second. Mm-hmm. The second stage is burning. It will burn for 3.5 minutes. And that will take us to more than 100 kilometers of altitude, almost 120, and 16,000 kilometers per hour. But first we'll see the fairing come off. We should have been going through max Q approximately at the time of separation. That's the highest heat load, so it can reach a couple of tens of kilowatts per square meter, and you do want something protective over the payload when that kind of heat load comes in.
Yeah, so what we've just seen, ideally this is how it works. Obviously that wasn't a real image, it was an animation for us to get an idea.
Yes.
Yeah.
So the next step should be the separation of the fairing.
Yeah. Now all these empty stages, the first, the second, the third stage, I mean, they're all burning off and then they're being dropped where? What's happening to them?
They have designated drop zones where these stages fall. And
so where shouldn't I go next?
Well, you're not allowed to go there. Okay. But the first stage, so because you're firstly going up, the first stage drops very close to the launch site. And even everything up to the second stage drops within less than 2,000 kilometers of the launch site. It's only the third stage that travels really far. That travels, it's dropped, it almost reaches orbit. It's just suborbital, and it will fall into the Pacific Ocean.
Now, there are these 3 stages, and then there's another one called Breeze. The others don't have a name. What is the significant difference here?
Well, they do have a name, I suppose. I can't remember it. But,
okay.
Those 3 stages are in itself a self-contained rocket. So if you want to go to low Earth orbit, you just use the 3 lower stages. But if you want to go to anything beyond low Earth orbit, you have to use the Breeze on top. And then you still have a differently commanded, pre-programmed ascent profile for the 3 lower stages. But then the Breeze stage is much cleverer than the previous ones. It can start its engine, switch it off again, turn, wait, switch it back on again. And it can survive up there for 24 hours. So it's really a self-contained spacecraft. So we can consider the breeze with Exomars on top as a spacecraft until the separation occurs.
So it's intelligent. What are we seeing here right now, by the way?
We're seeing the ascent trajectory the way it should be. As it curves away, you see it goes up first and then curves to the northeast. Actually, we have to go to the northeast. We don't go directly east. We have to go to the northeast so to skirt. So you see the ground track. If you plot it on a map, it would be skirting Mongolia. So it would stay just inside Russian territory. All of this has historic reasons.
Okay.
And then we will see it going out over, reaching orbit above the far east part of Russia. That's when final orbit of 175 kilometers, the parking orbit will be reached. And then we're going to have about a bit more than an hour of waiting until breeze boosts the whole stack into a higher orbit, eccentric orbit, which goes up to 5,000 kilometers. Then we have to wait for about 2 minutes. Sorry, we have to wait about 2 minutes, and then it will go into another higher orbit again. And then we have to wait. Then comes the excruciating part. We have to wait for 6 hours. And sorry, did I say 2 minutes? 2 hours, and then 6 hours wait. And then will be the final burn. That will be the fourth breeze maneuver. It will be about 8 o'clock our time by then.
Exactly, it's a long day. Yeah.
Yes.
And I just hear that the second stage is gone now, and the fairing jettison is basically happening as we speak right now. What exactly happens? Because we can't obviously see it.
Well, when the fairing is jettisoned, it falls apart in two petals, and these fall to the basically they fall back to the Earth. They don't have orbital velocity. So after that, we'll be looking at the third stage, and the third stage burns for 4 minutes, and then there will be a short coast arc when the engine, the breeze hasn't switched on yet, and then we'll see that running for a bit more than 5 minutes.
Yeah. By the way, I've mentioned earlier, I'm sure you heard it, that the launcher, the Proton-M, is one of the largest, heaviest rockets in the world. Why was it chosen, the Proton-M?
We have the heaviest spacecraft ever sent to Mars, and this spacecraft has to be accelerated to a high velocity. We leave the Earth with 3.7 kilometers per second, so that's really high. That's a lot. So in order to achieve that, we need a big rocket. So the smaller rockets of Soyuz or that kind of class that launched, for instance, Mars Express, would not have been able to make it.
So you need a real powerhouse to push it all up. And I mean, of course, this breeze is in this sort of elliptic orbit, and it gets even more elliptic, and it passes a radiation belt, which I find a bit scary.
Well, that's inevitable. It's in a circular orbit. It's below the radiation belt, and then after the first maneuver, it will push up the highest part of that orbit to 5,000 kilometers. So definitely, it will be going through the Van Allen belts, the radiation belts, and twice, once on the way up and once on the way down, and then on the second orbit again. There's nothing you can do about that. You can just make your spacecraft resist that, but actually it's not anything that's so unusual. It happens also to geostationary satellites.
Okay. Now then, of course, your day job is calculating orbits and trajectories, and then there's a team, and they basically figure out how the maneuvers must be. This mission, when is it expected to reach Mars?
This mission will reach Mars on the 19th of October.
The 19th of October.
Yes.
We can all pencil that down already. That's written in stone. That's a fact.
Absolutely.
19th of October. If you have any dates, cancel them. 19th of October this year. A big, big day. And if you don't believe me, we have prepared something for you to take a look what's happening on the 19th of October.
3 days before reaching Mars, the two elements of the Exomars 2016 will separate. The Schiaparelli entry, landing and descent demonstrator will detach from the trace gas orbiter. The aerodynamic lander will make a controlled entry into the Mars atmosphere. To save power, it'll coast through the first phase of descent before reactivating and entering the Martian atmosphere at 21,000 kilometers per hour. The lander's speed will then be reduced by a protective heat shield and a parachute. Schiaparelli's primary purpose is to test and send back entry, landing and descent information, which may be vital to future missions. In carrying out its demonstrator function, Schiaparelli will provide other scientific information, such as the characteristics of the Mars dust environment. The lander will send back data for several days after touching down. The trace gas orbiter, meanwhile, will enter orbit around Mars some 400 kilometres above the surface of the planet. The orbiter will act as a telecoms platform and a science observatory. As its name suggests, it will identify trace gases and analyse the atmospheric chemistry of the tenuous atmosphere. It will also study the surface and examine the Sun during Mars sunrises and sunsets. A high-resolution camera fitted to the orbiter will investigate slope-linear, dark lines believed to be associated with liquid brine. These increase during spring and summer and decrease in autumn and winter. The orbiter will also investigate deposits of ice water on the surface and up to a metre beneath the surface. The trace gas orbiter will remain in orbit to support the 2018 Exomars rover mission.
All right, 2018, the next opportunity for us to launch another mission to Mars. Now this one is on its way, and I just heard that the third stage has burned. But let's talk a bit more, Michael, about that breeze upper stage. So it's doing these elliptic orbits, passing the radiation belt, pushing the launcher higher and higher. But it's also very clever, you said already, it's a spacecraft that can do a lot of things. And it's actually tilting so that the solar arrays that are not yet unfolded can get a bit of light. Why is that important?
Well, it's a long time, and it's necessary to keep the batteries topped up, so to speak. But also, we might have thermal problems otherwise, so we have to be sure that nothing gets either too hot or too cold. It's always a concern in space.
And how precise is the trajectory of the Proton launcher?
Well, Proton is a reliable launch vehicle, and it's been used a lot of times. It's been continuously improved. And of course, nothing made by humans is ever completely precise, but we're going to correct for any imprecision in the escape in the days after launch. Once we've determined the orbit, we foresee a slot where we correct, where we perform a maneuver and put ExoMars back on track.
All right. Now, the breeze is going through several stages as well. It can switch itself on, off. I think there's 3 stages. Can you go through those for us once more?
Well, there's first a maneuver that puts breeze itself onto this low orbit. And then there will be the maneuver that inserts into an orbit which goes up to 5,000 kilometers, then 21,000 or 22,000 kilometers, and then the final escape maneuver. And between before the final one, there will be a tank, an empty tank on the breeze that can be jettisoned. And that way, the breeze will just rid itself of almost a ton of useless dead weight.
So it's really intelligent. It decides this is empty, off with you.
This is very well designed, I'd say. Yes.
Very well designed indeed. Now, of course, as we're nearing Mars, the orbiter and the lander, they'll be too fast. There'll have to be some very, very specific maneuvers in order for it not to go elsewhere.
Well, the lander will just enter the atmosphere with arrival velocity, so it will enter at about 21,000 kilometers per hour, and then will be break down by the atmospheric friction. And this doesn't work for the TGO, so it has to turn around, and it has a main engine on board, and it has 2 tons of propellant to slow itself down. So it will be braking, and after that, it will have shed sufficient of its velocity to be in a captured orbit around Mars. And from there, we have to execute some more maneuvers and also engage in something called aerobraking, very tricky business. That will take a long time. It will take us almost to the end of 2017. And then finally, the spacecraft will be in its final science orbit.
Now, you've calculated this flight, and then I said already that there are these experts who then, with your calculations, figure out how the maneuver works. Do you have a say in that? Are you happy with what they've come up with? Or is there anything that worries you right now?
I'm quite happy that they verify everything I've done, and it works also the other way around. each of us checks what the other has done. That's simply, it's not a sign of mistrust or anything. It's just better to do it that way. So we all work extremely well together here.
So it's a real team effort, which I think is absolutely necessary for a project like this. Michael Kahn.
It's an international team effort. It's not just ESA, it's our Russian friends, it's industry, also the Americans. Space flight is teamwork.
Is teamwork. Thank you so much, Michael Kahn, for talking us through all these events. Thank you. Thank you so much. And we are well 10 to 15 minutes into the flight of the Proton launcher now. By the way, this is not actually the Proton launcher anymore as we know it, because the Breeze upper stage has taken over, as we heard, a very clever one here, and it's already performing its first burn at this stage. And this is why this is a good moment for us to go to the main control room again, to Micha Schmidt. Now, you're not right now controlling the launch, obviously, Micha, but do you have information about the first Breeze burn already for us?
Yes, this I can confirm. We get nice reports from the MCCM from Moscow. So as far as I can see now, it's really like a picture book performance. So I have announced the start of the first burn of the Breeze upper stage.
Okay, well, that sounds good. Picture book. That's what we want.